Hello everyone, welcome back to my channel Ordinary Data Scientist, where we talk about data science. So friends, today we will cover the chapter 4 on probability. I think you might have studied this chapter in class 9th and or probably 11th. One of the chapters that we have studied there was combination and permutation, you remember? So permutation, yeah. So most of the concepts that we will study in this chapter will be related to combination and permutation only, and probability that we might have studied earlier, but we will try to contextualize the learnings from this chapter to statistics, like how we can use probability, permutation and combination to derive some of the statistics from the sample or population, and how to get some business insight, right? So some of the learning objectives are noted here. Like you can see, we need to learn some kind of probabilities. Like there are mainly 3 kind of probabilities, how to compare different kind of probabilities, and also we'll try to derive some of the probabilities using some concepts. Okay, now let's take an example of probability. Now if you see, India is playing in Olympics, right? India in Olympics. Now if I say, hey, what is the probability of winning, let's say winning gold in badminton, right? Like what is the probability that India will win the gold in the badminton? So based on something you will say that, hey, there is 50% chance that India will win the gold in badminton, or India will win the World Cup, Cricket World Cup. Probability is 50% of winning the World Cup, and so on and so forth. So we always try to forecast any event using a probability, using a chance of occurring that event, right? So that's what the use case of probability in real life also. As I was giving example in one of the earlier lecture, that if you are a manufacturing company, right, you won't directly enter into a new market, right? You will collect the sample from the new market. This is your new, let's say this is your new market. You will collect the sample from the new market, you will do your research, and then you will make a kind of insight that, hey, based on this sample, I think that 50% chance that the product will be successful in this new market, right? So that's the objective of the probability. In statistics, in the business world, we'll try to learn how to derive these probabilities using some of the concepts. Okay, so here is the example that I just mentioned, that you from the population you take a sample, and using this sample you do some computation and then make a reference or inference about the population. So that's how the logic works. Okay, now there are 3 kinds of calculating the probability. Let me list it down. There are 3 kinds of good. The first of the kind is that what is the what we call is also like your classical method. Now in this classical method, you already know everything. Like for example, this is the class where you have the male population, let's say 50, and female is your 70, so total is equal to 120. If I ask you that, hey, if I randomly pick one student from the class, let's say one student I pick randomly, what will the probability that it's a male? So you will say, hey, 50 by 120. What is the probability of being a female? You will say 70 by 120, right? This is the case of a classical method where we know the desired outcome and total number of possibilities, right? So we divide it by 50 by 120 or 70 by 120. So if I write the formula of this classical method, it will be, let's say, probability of being any event is equal to NE, is how many possible outcome of this event are divided by total outcomes. Yeah. So people, if you have noticed here, is that the probability of getting any event is equal to possible outcome divided by total outcomes. So here if you see total outcome was 120 and all. So probability will always be lesser than or equal to 1, because the numerator will always be lesser than the denominator, right? Similarly, the probability is a ratio of 2 positive numbers. The event outcome events or favorable outcomes will not be negative. It will never be negative because these are count, right? These are not like 1 kg 2 kg or something like that. These are count 1 2 3. Okay, so that's why probability will always be greater than equal to 0. It can be 0, but it will always be greater than equal to 0. So probability will always lie between 0 to 1, right? So this is one thing that you should always remember. If you are getting probability greater than 1, that means there is a problem in your formula. Okay, now the second method, we call it relative frequency method. Relative frequency method. Now in this method, the relative frequency method, as earlier we had the fixed numbers, right? Like 50 only, 120 or 70 only, right? But in relative frequency, this won't be fixed. It will keep increasing based on the number of trials or number of experiments you are performing. Okay, for example, if you, let's say, if you are having if you are checking, let's say this is your day 1, similarly day 2 and day 3 and day 4. Okay, now event, I'll say rain, no rain, rain, no rain. So if I say, hey, what is the probability on day 5? If I ask you on day 5 that what will be the probability of rain, you will say, okay, I had seen that historically 2 days it rained, 2 days it didn't. So the favorable outcomes were 2 and total were 4. So you will say 50% probability, right? Now let's say in let's say day 5, when the day 5 happened, day 5 rain happened, right? So if I say that, hey, what will be the probability of rain on day 6? So you will say, hey, rain will be, now 1 2 3, there are 3 favorable cases and divide by 5 total cases. So this is like 60%, right? Now on day 5, on day 6, it actually didn't rain, no rain, right? So if I ask you, hey, what will be the probability of rain on day 7? You will say probability of rain is equal to, now you will count 1 2 3 divided by, there are 6 days, 50%. You notice that the probability of rain keeps increasing based on the actual data point that you are adding to the data, right? We added 3 data points and the probability kept changing from 50 to 60 to 50. So this is called relative frequency because it depends on the relative occurrences, like how many total events you are calculating and how many favorable event has occurred in the past. Okay, that's why it's called relative frequency. So formula remains same, that favorable divided by total, but you need to cut off the time period only and then check the historical period. Okay, so if I come to the formula of relative frequency, you see total number of times an event occurred in past divided by total number of opportunities for the event to occur. So this is called your relative frequency. Now another is subjective probability, as it says that it's a subjective, means it can change. So if you are bringing person 1, let's say if I bring a person 1 and ask him that, hey, what is the probability of rain, based on his assumption and everything, he will say that, hey, it's a 50% chance that it will rain. But if I bring another person B, and if I ask him, hey, what is the probability of rain, based on his or her experience, he might say that, hey, it's a 45%. So this is subjective, and there is no formula associated with that, and most of the time these are the experts from where we get the probability. Like for example, if you take any example of geopolitical situation, if you talk about Afghanistan nowadays, you might read about the news what is happening there currently. So I'm talking about September 2021. If you read any news from this time period, you will see what is situation happening in Afghanistan. Now most of the experts who are expert in, let's say, in economics or in politics and all, they might be giving you probability that, hey, there is 50% chance that the new government will be successful, or there will be 80% chance that the new government will fail, based on their expertise, right? So that's why it says that it's a accumulation of knowledge, understanding and experience over that. Okay, so if you have the data point, definitely you calculate using the classical method or using the relative frequency. But if you are an expert, like for example the case of Afghanistan or something like that, you will do a subjective probability. Now these are the three kind of probabilities that we had studied. Now let's try to understand the structure of probability. Okay, now if you see, we had the first thing we had was experiment. How many times we did the event, like if we counting the number of days, how many days it was. If you count the number of days, like here 1 2 3 4, like it's each experiment we are doing, right? Experiment 1 2 3, something like that. So these are called experiment. Similarly, if you roll a die 2 times or 3 times or something like that, it's also called experiment, rolling a die. So if you roll it once, it will call one experiment, right? If you roll it twice, it will be called 2 experiments, something like that. Okay, the second is your event. Now event is your outcome, nothing but your outcome. It can be favorable, it can be non-favorable, but it's the outcome. For example, if you toss a coin, so tossing a coin is an experiment, right? But the outcome, head or tail, is the event or the outcome. Okay, so these are the experiment and event. Third, you need to understand is the elementary outcome. So if I take example of here, head and tail, so there is no other probability that I can get head in different ways or something. So this is elementary outcome. Tossing a coin and getting head and tail is an elementary outcome. But if I say, hey, I roll a die, and what is the probability that I will get an even number? Okay, so even number will be 2, 4 and 6. So rolling a die, getting an even number is a outcome event, but this is not elementary, because elementary will be getting 2, 4 or 6. This is even numbers, right? So this is called elementary outcome. Okay, fourth is your sample space. So sample space is nothing but your collection of all possible outcome, collection of all possible outcomes. Okay, so to visualize it, let's say you pick 2 die and roll them together, right? So if you roll them together, what will be the possible outcome? So you will get the outcome such as 1, 1, 1, 2, 1, 3, 1, 4, 5 to 6, right? Up to 6, 1, 6, 2, up to 6, 6, right? So these are the possible outcomes. So there will be 6 into 6, that means 36 possible outcomes. So this is nothing but your sample space. Now any particular combination might have occurred, but this is the possible outcome. So this is called sample space. Another key terms we need to understand is unions or intersections and those kind of thing. Intersections. So union means if I have, let's say, x is equal to your 1, 2, 3, 6, and your y is equal to, let's say, 3, 4, 5, and if I say, hey, x union y, so that means it's a combination of all the elements. So I 1 2 3 is here, 1 2 3, now 4 5 is here, 4 5 and 6 is here. So x union y will be 1 2 3 4 5 6, all the elements. Okay, but if I take the same example of x intersection y, intersection y, that means the common elements from these two sets. So the common elements is 3 only, right? So x intersection y is 3, while x union y is equal to all these elements. Okay, this is union and intersection. Now there are a couple of more terms like mutually exclusive. Mutually exclusive means the occurrence of one event won't affect any other event. Okay, now if I roll a die, getting 1 is independent of getting 2, is independent of getting 3, is independent of getting 4. All the probability of getting each element is 1 by 6, 1 by 6, 1 by 6, right? It's independent of each other, mutually exclusive, right? So in the mutually exclusive, the x and y intersection will be 0. So if you read here that the probability of two mutually exclusive events occurring at the same time is 0. Either you will get 1 or either you will get 2 or 3 or something like that if you roll the die. So probability at the same time is 0. Okay. Another term is your independent events. Independent events. Now independent events are kind of your two completely different experiments. It's like two completely different experiments, right? So for example, probability of rain will not be impacted by probability of getting 1 in the die, 1 or 2 or something like that. It's independent. These two experiments are completely independent, right? So this is called independent events. Another terms like the collectively exhaustive events contains all the possible elementary events from the experiment. So the sample space that we had seen above, this one, the table we just show is that only. Okay. Now another term is that complementary event. So complementary events means either it happened or it didn't happen. You can think like that. If you toss a coin, either you will get head, probability of head is equal to 50, or you will get tail, right, is equal to 50%. The probability of getting head and tail is 50%. So can I say that probability of head is equal to 1 minus probability of tail? Can I say that? Yeah. Similarly, if you roll a die, you will get 1, 2, 3 up to 6, 4, 5, 6. So can I say that, hey, probability of getting 6 when I roll the die is equal to 1 minus your probability of getting 1 plus probability of getting 2 to probability of getting 5. Rolling a die and getting 6 is equal to 1 minus probability of getting everything, right? Everything else. Cool. Elementary. Now counting the possibilities. Now counting the possibilities is important thing to learn, because you need to divide it by the favorable outcomes. Okay, so how to count the possibilities, the denominator actually. So there are multiple ways of doing that. One can be like, if this smaller set, you can literally count on your fingertip. Like, okay, if I toss a coin, the possible outcome is only 2, right? Either head or tail. Similarly, if I roll a die, the possible outcome is equal to only 6. Either it will be 1, 2, 3, 4, 5 or 6. So these are the possible outcome. Now think like that. If you have a bigger sample set, if you have bigger sample space, you cannot count them on a fingertip. So you should have a formula, right? Cool. The first formula that we have is mn, means m multiplied by n. Okay. So this formula will be applicable when you have two different experiments, experiment 1, experiment 2, and then after doing all the both experiments, you want to get the outcome. In this manner, you have to multiply the possible outcome in experiment 1 into possible outcomes in experiment 2. You have to multiply them. Okay. For example, let's say if I roll a die, what will be the possible outcome? So I will say there are possible outcome of 1 to 6, that means 6. If I roll the same die again, what will the possible outcome? So I'll say, hey, 1 to 6. So these are the 6 outcomes, 6 events, and 6 I say events. So if I say that, hey, if I had rolled the dice twice, what will be the probability that I had get in the first occurrence 1, in the second occurrence 2, right? What is the probability? So I'll say that, okay, the favorable condition is only 1. I just want 1, 2. That means in the first experiment I get 1, in the second experiment I get 2. So there is only one possible favorable outcome, and the total outcome 6 I have done here, 6 here. As these are two different experiments, it will be 6 into 6. That means 1 divided by 36. Yeah. People, if you didn't understand why 6 into 6, I'll request that you should quickly revise the previous concepts which were taught in earlier classes, like the permutation, combination, because there we had learned how to calculate or count the total number of possible outcomes, right? So please revise that. Otherwise, let me quickly explain this here. So the possible outcomes is you get 1, another you get is like when you roll the dice, you will get 1. When you roll the die second times, you get 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, that means you roll first is your 1, but second can be anything. Similarly, 2, 1. If you complete this to 6, 6 and count how many terms, how many events are there, you will get 36. Okay, 6 into 6 combination. There are another ways of counting the events, that is you're using the permutation and combination. So I always prefer that permutation and combination method only. So for example, if I take the example of this same case, let's say if you had rolled the die 1, the possible outcome is 6C1, that any combination might have occurred from 6. Similarly, if you had rolled die 2, the possible outcome will be 6, 1. So together there will be 6C1 into 6C2. That means 6 into 6, 36. That's how you calculate the events, right? So these are the different ways of counting the events. You can study, you can remember, or you can understand them also. Okay. The another event is your sampling from the population with replacement. Now, with replacement is an important term that we have studied multiple times while solving the permutation and combination, right? So for example, with replacement, what does it mean? If you have a box and you have, let's say, 10 balls, okay, total 10 balls, and let's say 10 out of 10 there are 4 red and 6 black. You do experiment 1, and if I ask you that, hey, what is the probability of getting red, you will say, hey, I will get red by probability of 4 divided by 10. You do the second experiment with replacement, that means you put the ball back and you say that, hey, what is the probability that I will get a black? So you will say that getting black will be 6 divided by 10. Now if I say that, hey, combine this probability, and if I say that, hey, what is the probability that I would have get red first and black then, you will say that it will be 4 divided by 10 into 6 divided by 10, right? So that means be 24 divided by 100. So if you see, the possible outcome is 10 into 10, So if you do the replacement, that means you can do a square of that also, like n is your total number of size, and raised to power small n is your sample size, right? Population size raised to power sample size. So if you had done this experiment thrice, it will be 10 raised to the power 3. That possible outcomes. Okay, cool. So that's how we will calculate the possible outcomes, people. If you haven't understand this, how to get 24 divided by 100, so please try the same logic here, but please think that all the balls are different. So if I say that this is R1, red 2, red 3 and red 4, others are like black 1, B1, B2. So do the sample space like that, R1, B1, R2, B2 and something like that. You will get total 24 possible outcome, and divided by 100 is equal to your total outcomes. Okay, cool. So that is the logic about calculating the number of possible outcomes, possibilities. But people, if I say that you don't need to remember this one, you don't need to remember this one, if you understood this logic brilliantly, you can always apply the permutation combination to get either this or this. So you don't need to remember the first two. So focus on this to understand wherever we need to apply the NCN, and you will get the same results from other two. Okay, cool, people. So please quickly revise the concept discussed in this chapter, and if you haven't gone through the chapter, or if you had forgot some of the concept from the permutation and combination chapter, I'll request that go and visit those chapters once again on Google or YouTube, so that you can understand the possible outcomes, favorable outcomes, and feel comfortable applying the NCP formulas. Okay, so with that, I'll take a pause here. See you in the another video. Thank you.